Jerry here. In this video, I'll be creating a compact retro computer emulator for the Commodore 64. Despite its size, it boasts some impressive features. It boots in around 4 seconds. It can be powered off at any time without worrying about corruption. It is extremely fast with low latency. It exhibits high compatibility with original Commodore 64 software. It offers high quality HDMI video output. It comes equipped with ports for the original joysticks, as well as having USB connectivity so you can use modern gamepads. How does it manage so much in such a small package? Well, it runs on a Raspberry Pi, but it operates as a bare metal emulator. In simpler terms, there's no Linux installed. It communicates directly with the Pi's hardware. And if that weren't enough, it is designed as a replacement for the Commodore 64 motherboard, allowing direct wiring to the original C64 keyboard. This is a simple way to modernize an old Commodore 64 unit while preserving the original aesthetic and user experience. Although I won't be doing that in this video, I will be providing the details on how that is done, and this is something I will attempt in another video. Considering a Raspberry Pi 3 can be acquired for around $40, this method seems like a bargain when you consider the costs involved in updating an original unit. If you want to get an original Commodore going, then you have some of these costs. A new power supply, because the original ones have a tendency to blow up the motherboard. I recently paid $80 for one. A third-party device upgrade for the graphics so you can attach it to a modern TV, and probably some form of fast loading device to get the games loading quickly. If you like the sound of this, please join me as I guide you through the project. I'll point you to all the necessary information, perform some soldering, set up the software, and then put the entire system to the test. The PCBs used in this video have been provided by PCBWay. If you haven't come across PCBWay, they are a manufacturer of PCBs, obviously. They also do 3D printing, CNC machining, but they're known for manufacturing high quality PCBs. Another great feature, the shared projects page, is where you can find designs uploaded by engineers for you to order directly from PCBWay. This is where I got the PCB designs that we're going to be using today. So we're starting with this one here. I'll leave the links to these in the description, but this one's done by the engineer C64 Istanbul, who I've looked at a lot of his stuff on here. He's got a fantastic amount of designs for retro computers. So it's called the bare metal C64 Plus keyboard. So on its own, it doesn't have this white cover. That's a separate PCB, which you can find here. It doesn't do anything apart from give you a nice look, and it gives you all of the layout of the keys, which is actually really important because the C64 does not have a standard keyboard, so you can't just plug in a USB keyboard to this project and expect the keys to match. You need to have some form of reference, and I found this actually was really useful in the end. The other PCB that I ordered was this. I won't be using this PCB in this video, but I just wanted to point this out, that you can actually replace the motherboard inside a real Commodore 64 or VIC-20 case with this project and use the existing keyboard and have what looks, to all intensive purposes, to be a real Commodore 64 with modern electronics. You'll get HDMI output and be able to use USB input devices. I had a few comments in my previous video with the retro VGA. Some people loved the inbuilt keyboard. Some people thought it was a bit of a gimmick. I found with this project, it's essential to have a keyboard, and it's very convenient to have the mini keyboard built into it. Because the Commodore 64 had an inbuilt keyboard, many of the games actually expect input from the keyboard. It might prompt you for pressing F1 for one player and pressing F2 for two players. It might say press the spacebar to begin. It might ask you to type in your name. Obviously, you can plug a USB keyboard into it, but you will have to map out the keys. So probably you need to print out some sort of reference sheet to help you out with that. And I think it spoils the aesthetic of a miniature computer having a really large USB keyboard sitting beside it if you're trying to use it in your lounge room or something like that. This is the package I got from PCBWay. So these two PCBs go together to make the miniature computer with its built-in keyboard, like that. And this one over here is made by the same engineer, and it's called the Geeks Edition. We're not going to be making that today, but it has some other features that I wanted to point out because they're really interesting. Let's say that you have a Commodore 64 that has a faulty motherboard and it can't be repaired. Or you want to reuse the shell and replace the motherboard with this project so that you can take advantage of the HDMI output and the connectivity with USB so you can use other input devices. You can actually separate these two PCBs, there are perforations here, and create the project. But there are extra pins here that allow you to connect the real Commodore 64 keyboard to this board. Alternatively, if you've got a Commodore 64 that you think has got a good motherboard, but the keyboard isn't working, you can actually use this keyboard and connect it up directly to the motherboard. That's probably only useful if you're trying to debug it, but that's why this is called the Geeks Edition. Hey, it's Future Jerry here. I finished the video and then I realized that the BMC64 guys have designed their own PCB to fit inside a Commodore 64 case. And this one actually has a power outlet and it's designed to fit in the existing holes. So this might be another alternative to the Geeks Edition. And when I went to PCBWay's projects page, I found that you can order this PCB from them as well. So in this video, we're just interested in this project. I think this is a great project for beginners who perhaps want to start getting into soldering because it is very simple. We've got our buttons that are going to get soldered onto here. We have some headers that need to go onto there, and we've got our serial ports for the joysticks that go onto there, and that's about it. I think there is a resistor here and a LED here, which are probably optional. And that's it. Put it together and we have ourselves a miniature working Commodore 64 with inbuilt keyboard. Okay, so let's get this thing started. So it's normal to put the lowest profile components on the board first, so they don't get in the way of soldering the other components. So this resistor here, I think its only purpose is to limit the current to the LED. That's a 470 ohm resistor that I've put there. Next we'll put on the buttons. I've just propped that up a little bit so the glare doesn't drive us mad, and it's just a matter of placing them in. I did notice that some of these buttons aren't as good as the others. If you get a batch of 100, you're bound to get some that aren't quite as good, so it would be worth actually testing them out before you soldered them in. Yeah, we just got to repeat that. All right, well that was a pain. It took about half an hour, I think, to get those buttons in. So what I'm going to do now is just try and fit this plate on, because I can use this plate to press down on the buttons when I solder it. Just having a look there to see how I've done. They all look pretty good. Just want to be careful. So if I use these rubber bands to hold it down, that should give me the opportunity to solder them and have them sitting flush. That's the plan anyway. I'll have to wait and see. And I'm just going to press all of the buttons just to make sure that they all work. That's really good. On to the soldering. Just a quick note on soldering components that have more than 2 legs. It's always best to solder only 2 of the legs on first, then check to see whether or not it's flush and solder the rest of the legs. If you only solder 2 sides, then you can heat up one side, adjust it, heat up the other side, adjust it again, and do that until you get the component properly in place. I'm not going to do that because I have this plate that is pushing down and everything is sitting flush. Perfect. Going to install the lead now because it's out of the way. It won't get in the way of soldering other things. So the longer lead is the positive, the anode. I'll just put that in there. And if I put this facier back on it, I should be able to get it into the right position. Just push that down. And I'll just solder one leg and then check it. And then if it's right, I'll solder the other. That looks pretty good. If I hadn't got it quite right, what I could do is just remelt the solder on that one leg and give it a bit of a push. And it will come out further. The next we need to solder the headers on. So the headers need to go on the bottom of the board because this is going to attach to the board like this. So the headers need to be on the bottom. It says here to use a dual package 20-pin connector or 40-pin connector, so 20 pins on each side. I don't have one of those, but I do have plenty of single sided ones. You can make that fit. I think we'll use white. We'll keep with the black and white color scheme. Now, this is a 40-pin connector and I need 2 20 pins. So you would think that I would be able to cut this in half and then use the 2 halves. But what I found is it's almost impossible to cut perfectly between the lines and you end up with one of the pins hanging off the end. So what I'd like to do is just use 2, and then one of them will be 20 and the other one will be 19. I'll reuse the 19-pin one in another project for something else. So the way I like to do this is just to mark the 21st pin and then remove that pin completely just by yanking it out like that. And then scoring it a couple of times. And just snapping it. So now I've got a 20-pin one and I've got a 19-pin one. So I'll reuse that for another project, and it's reasonably clean. I don't really care about this because it's all going to be hidden. What I like to do is just to double check by placing it in place, just to make sure that I've got it right. And then I can use that one to just quickly mark off on this one. And do the same thing. Just a matter of soldering it on now. So with the soldering, I'm just resting it on there, and it's probably going to be misaligned. And this is the point I was trying to make about only soldering on 2 pins at either end. So now I can come back to this and I can readjust the header until I get it the way that I want it. That's sort of leaning over a bit, so I can just have to be really careful not to put my soldering iron near the buttons. Maybe I should have done this first. It looks pretty good. So I will just solder that in its entirety now before we move on to the second one. Yeah, I'm thinking now I should have soldered on the head as the first thing I soldered. Because now that resistor, which I thought was the lowest component, is now getting in the way. Okay, so you can see how badly that is aligned. So it's just a matter of heating this up, pushing it down. Do that on either end until I get it exactly the way that I want it before committing to soldering the other pins onto it. Just a quick note. Let's say that I accidentally damage one of these buttons when I'm soldering this on, and you want to remove the button. If you've got a solder sucker, you can probably do that, and you might be able to do it with some of this wick. If you can't though, another easy way to get them off, and in fact the easiest way to get them off, is to actually simply cut the legs from this side, all 4 of them, right? Pull the button out, and then you'll just be left with 4 little wires essentially, and you can desolder them one at a time. Just apply the solder and pull them out with a pair of tweezers. Just the serial ports for the joysticks left to go in. Make sure I've got the male ones this time, because the last project I used female ones. I had to swap them out. So these just slot in. Nice. Use the same little trick just to make sure that they're sitting as flat as they can be. I'll just apply the heat to both pins, pushing down. These look pretty good actually, but okay, so I just need to solder the rest. And then just these anchor points here. That's it. How simple was that? All done. Time to attach this board. It's got 3mm holes around the outside that you can put screws through. I find this a real pain. This is finding the right screws. I just happen to have some from my drone that are 3mm by 10 mils, I think, and these are going to work. But yeah, so the retro VGA board that I did had 2mm holes, which were way too small to find screws easily. But what I ended up doing there is I just soldered wires through from one side to the other to hold it together. So I think I'd prefer that in this sort of design. If they had a couple of holes next to these, then if you chose to, you could just solder wires to hold this board together, which means, of course, if you want to remove it, you're going to have to unsolder them. But I mean, that's no problem for me. And there we go, fully completed. Boards that I have lying around that I'm going to test out with this are going to be a Pi 0 and a Pi version 3. Obviously the Pi 0 is not going to be as powerful, so expecting reduced performance with this. But given its size, it's pretty much going to fit underneath the PCB like this, and it'll be completely hidden. It makes a neater build. Whereas with this one, the Pi 3 or larger, it's going to sit like that, which is still pretty all right. It gives you access to all of your USB ports and obviously your HDMIs. So that's really good. But I do want to try both of them. With the Pi Zero, I'm going to have to solder the headers onto the top. A lot of times people solder the headers onto the bottom to put it onto a breadboard. But in this case, we're going to need it on the top for sure in order to make it work with this. So it's going to go this way so that all the ports are facing outwards. The slots in there. You can't even see the Pi Zero in this configuration, but you've got a HDMI out, you've got a couple of serial ports, and you've got your joystick ports. All very nice and neat. So with the larger Pi board, it's going to go like this. So once again, you've got your HDMI out. With the larger Pi board, obviously you've got audio out, so you don't have to rely on HDMI audio. And you've got everything else poking out the side. Still a neat little package, I think. You could quite easily keep that in your drawer and pull it out, and away you go. I like it. So I guess it's time to move on to the software and testing. I'll put a link in the description to this video. This is Randy Rossi, the creator of the bare metal Commodore 64 project. He goes into a great amount of detail on why he created this, his motivations, etc. So it's well worth watching this video if you get the opportunity. This is Randy Rossi's GitHub project. This is where you'll find the source code for this. You don't need the source code. I'm going to show you how to install this, but it's interesting to come here and have a look at what he has to say. So, you know, his features here: quick boot time, so 4.1 seconds. It talks about the frame rate, low latency with the input and the audio. And this one here, no shutdown sequence required, is actually one of my favorite features, because if you're using a Raspberry Pi, it's running a Linux operating system. It's not designed to be just turned off, unplugged. There is no easy way to shut it down. So you basically just have to take the risk and power it off. And at some point, it is going to corrupt the SD card and it's going to fail to boot. So that's one of the great advantages of this. You don't have to worry about that. Obviously, the high compatibility with Commodore 64, because it's based off the Vice emulator, and a whole bunch of other stuff, including the fact that you can use a real Commodore 64 keyboard with it, and obviously that allows you to place it inside a Commodore 64 case. It talks about the limitations of the USB gamepad. It says that it's limited, not all gamepads will work, especially wireless. I've got my PlayStation 2 USB controller to work with this, and it's absolutely great. So there's no hot plug and play of USB devices. They must all be plugged in before you start it. Not a problem, considering you can power on and off this thing and it will boot almost instantly. There's information here about the precompiled images, which is what we're going to use. We don't want to compile it from the source code. There's a lot of information here about how you can affect the video output. You can change the HDMI and the scaling options. There's just so much information here. I can't go into the whole thing. This is another interesting website. It's called Sential.com, I think. This has a lot of information about it. It's probably a bit more of an installation guide. So what we looked at in the GitHub was the source control, where you can get the source files. Here you can actually get the files that you need to install it. A lot of instructions here. I actually have a cheat because there's a lot of effort that you need to go into here, because there's kernel files and character gen files
that they don't provide. I guess that's got something to do with licensing. They're basically saying, look, here's all the binaries that you need to put onto your SD card, but you need to go to another website and find these different files here. Now I have a cheat for that, which I'm going to show you because that's quite a long process. I also found another video.
This video from Retro is the New Black YouTube channel goes into a lot of detail about how to set it up, where you can find the files that you need, etc. So check that out. There'll be a link in the description. We have a quick way of doing this, a cheats way, I guess you could call it. So if we go back to the projects page, if you go down here where he's got his instructions for setting it up, he's actually providing a link to an SD card image that has all of the files that we need on it. So all we need to do is download that.
So this is our downloaded file. Let's just extract it. And this is what we need to put onto the SD card. Just select all of those, copy them and paste them into my SD card. Just a quick note, this image file has come from somewhere. I have no idea. It's not the official one. So just be aware of that if you choose to use it. The only thing is we don't have any games. So if you look in the directory structure here, you'll see that there's carts, disks, drives, tapes. We're going to be putting some cartridges, games in here. So we go into the C64 folder and you can see there's already a couple of carts in there, delay joy, delay key. I guess there's some form of debugging. Not really sure, but this is where we need to copy our .crt files into. So I've chosen some games here that I thought would push the emulator. And we're just going to copy these down onto the SD drive. So into carts, C64. Done. All we need to do now is to take the SD card over to our emulator, plug it in, boot it up. All right, let me explain the setup. So we've got our Pi 0 connected into the back. We've got the HDMI cable coming out. That's going into a HDMI capture card. So hopefully that's going to capture the audio and the video. We've got a joystick, old-fashioned joystick here. And we've got a USB keyboard plugged into here in case we need it. I don't think we're going to need it because obviously we have a built-in one. So let's power it on. Okay, it's in. Bang, straight in. Cool. All right. So to get into the emulator menu, we have to hold down the Commodore key and F7. Right, that takes us into here. There's a lot of stuff going on in here and I don't want to get into too much detail because it would just take forever to explain it. Why don't we just go down and start playing games, because that's really why we came. And the joystick works, that's good. So I'm just coming down to cartridges. Spy key work, yes it does. Attach cart. And let's choose a game. That R-type. It's typing in the commands automatically for us to start that. Done. Okay, so what do we do here? Supply key, no. Space. And press space again to start playing. Now I can't see very well because this is plugged into, what's it saying? It's saying, oh yes, press F1 for player 1. Yeah, so don't expect any great gameplay or anything. Because of the way it's set up, I'm looking at it through a tiny little screen. Really just want to see what happens. Yes? Yeah, it looks really great. Joystick is responsive. So the video and audio that are coming out of it, don't expect that to be the real thing as if it was plugged directly into a TV. I don't think the capture card is going to do it justice, so... But I'll be honest with you, I'm amazed. You know, that tiny little Raspberry Pi Zero, which is an old one, it's not even the latest version, can actually run this. At least from what I'm seeing, I'm not seeing any problems at all. Okay, enough of that. So to get out of here, we press the Commodore key and F7 again, and I think that will take us back to the cartridges. And let's try something else. I did choose these games because I thought that they would push this little emulator, especially with the Pi Zero on it. What do we need to do here? Space. You can see why having the keyboard built into it is so important, because really there are keys that you need to press. Okay, press space to fire. Okay. Looking great. Really seems to be able to handle the sort of parallax. With the screen, you know, jumping around and moving fine. Well, like I said, I'm amazed. I mean, later on we'll be using the Pi 3, which is much, much faster than this. But I wanted to start with the Zero because, I mean, if it works with the Zero, that really is an indication of how well it works as a bare metal emulator. All right, so Commodore key F7. And that's the cool thing about this bare metal emulator, is not having to worry about trying to power the damn Pi down. And then wondering whether or not the SD card is going to get corrupt. So we're going to be using the same SD card in both of them, which is handy. If I can remember where the SD card goes on this model. Let's go. Oh yeah, of course, it's on the bottom. Yeah, so, and as simple as that. We just need to plug that in. So you can see it's not as neat, but it works pretty well. All right. So now we don't need these adapter things because this has proper size ports. So we've got a HDMI there. We can have our joystick back in. We can plug our keyboard, which we haven't even used, into that one. And away we go. So
power it on, see if it boots any faster. I didn't really check how for it to be fine with me, because if this was, you know, if you're using RetroPie or something like that running Linux on the Pi to do the emulation, you'd have to wait for the whole thing to boot up as well. So same deal, it looks exactly the same so far. Commodore key F7. We can go into here. No, cartridge, not tape. Attach a cart. Just try Ghosts and Goblins. I remember this is a hard game. Yeah, I mean, that all looks fine to me. I'm going to have to try this on a real TV, obviously, so that I can get rid of the capture card out of the equation. But, yeah. So really, the difference between the Pi and the Pi 0 and the Pi 3 isn't obvious to me. I'd really have to give this thing a thorough test to see if I could find any differences at all. But it's very cool that you can just plug either one in and it works without any problems. I have a feeling that the documentation said that a Pi 3 had much more compatibility with some of the PET computers that can be used with this emulator. So that might be another reason why you would choose a Pi 3. As great as the joystick experience is, I would like to try a gamepad. Now, I believe that there's no hot plug and play with USB devices, so you've got to power it off and power it back on, which isn't a real problem, I don't think, when it only takes a couple of seconds to boot. We'll go down to the Joy ports. Let's see what we can do here. Okay, so at the moment, we've got 2 ports, and one of them is GPIO1 and GPIO2. So those are the serial ports, are connected to the Raspberry Pi via those pins. I think what we're going to do is we're going to keep one of those to be the serial port, and the other one we will convert to be USB. So probably port 2. So there are lots of options. So cursor keys in space, numpad, USB mouse, custom key set, yeah. So USB gamepad 3. We probably want a USB gamepad 1. Okay. So we can configure USB gamepad 1. Go into that. The simplest way to do this is actually to go down to monitor raw USB data and figure out what the values are when you press the different keys and move different things. So if we go into that, this is the button that I want to use here, the X button. If I press that down, I can see that that's actually button number 10. If I was to press, so this shoulder button here, that's 1, and on the left hand side that's 0. So 0, 1 and 10 are useful values for us. So let's just go back. So 0 is currently set to fire. I think what I want to set it to is, I know this from previous experience, that you really want to be able to go back into this menu and back out of the menu is an important function. So we'll set that to 0. Was 0 the left or was 0 the right? That doesn't really matter. We'll find, because there's a back menu option somewhere.
So menu back, and number 10, which we can't see. If I scroll down, can I get to that? Can I see it? We want that to be fire. I can't see it. Just going to hide that for a moment so I can see. Okay, did set it to fire. Okay, we've assigned 3 functions to this. And it already had going up and down. So we need to go back. Yeah, so that one's now assigned to going into the menu, and this is assigned going back out of the menu. Cool. So let's see what happens. If we play a game, we should now have a working fire button. Yep, and now our fire button is working. And we can flip back to the menu. So there's a whole bunch of other stuff, obviously, that you can configure. You can configure all of the buttons on this gamepad, but also you can configure them with keyboard shortcuts. So anything that you can do on a keyboard, you'll be able to assign to this. I think we'll leave the video there. So I hope you enjoyed that. I'll put links to all of the information in the description. If you like what I'm doing, please consider giving me a thumbs up, subscribing to my channel, leaving a comment, all that good stuff. I'll catch you on the next one. Ciao.